It is time now to adjust the user interface for the work with the new version of the domain model, as well as the repositories we introduced earlier. I've updated the markup for the UI. Here is how it looks like now. This empty space here is devoted for the snacks. To display them, the view requires an additional property with the name piles, which returns a list of snack pile view models. Note the use of another view model inside of the snack machine view model. It's a common practice in the world of MVVM applications and is usually referred to as hierarchical view models. This is the snack pile view model itself. You can see, just as the snack machine view model wraps the snack machine entity, it works on top of the snack pile value object. It introduces several properties which basically transform those of the value object and present them in a form that is consumable for the view. Alright, to actually form a collection of view models, we need to get a list of snack piles first. So let's introduce another method in the snack machine entity. I'll name it getAllSnackPiles. Note that we return a read-only list here. It's a good practice to always do that to show the clients of the method that the collection is not mutable. In our case, the collection of the snack piles is indeed immutable. It should always contain 3 and only 3 elements. Also note that, just as with the getSnackPile method, here we expose a collection of value objects, not the collection of internal entities. That way, we maintain the encapsulation of the aggregate. To get all snack piles, we need to sort the slots by position, select the snack pile in each of them, and form a new list. And now we can use this method in the piles property. Good. You can see the view now displays the snacks in the machine: 10 chocolates, 15 cans of soda, and 20 gums. Let's now refactor our view model for the use of the repository we created, instantiating it in the constructor and calling the save method instead of working with the session manually. And the same in the main view model, where we retrieve the snack machine from the database. Perfect. Note that we now have 3 buy buttons instead of 1. Those buttons pass the number of a slot to the view model, so let's adjust the command to accept that number. The parameter's type is string, so I change the type of the buy snack command to the command of string. Parse the position here and pass it to the buy method. And we also need to update the notify client method so that it notifies the client about the change in the piles property as well. You can see when I insert a dollar inside and buy a gum, all works fine. The money goes to the machine and the number of gums decreases. But if I insert an insufficient amount of money, for example $1, and try to buy a snack whose price is $3, I get an exception. That's because the client doesn't check if all required prerequisites are met before calling the buy method. One way to fix this is to do all those checks here in the view model. In other words, do all the validations, check if the pile is not empty, if the user inserted sufficient amount of money, and so on. It is not the best design decision because those checks operate the data that resides in the snack machine and thus should belong to the snack machine class itself. Another option is to change the returning type of the buy_snack method to some value and use it to signalize an error. For example, we could return some string describing an error instead of throwing an exception, and that string could then be examined by the client. It is a better option, but still is not the best one, because it violates the command query separation principle. That is the principle which states that, if possible, we should separate methods that mutate the internal object state from the methods that just query some data from it. In other words, we should use void as the returning type for commands and make all other methods side effect free. In general, this principle helps us increase readability of the code. The buy_snack method here is a command because it mutates the internal states of the snack machine, and thus it should not return anything. So what should we do in this situation? The third option here is to introduce a separate method which gathers all checks for the buy_snack method and which doesn't mutate the object state. We can call it canBuyASnack. It's a common and yet quite powerful pattern. Basically, for each operation that has some preconditions which should be met, you can add a separate method that validates those preconditions. The client code then can use that method to do all required validations. So here we are getting a pile that resides in the position, and basically define all checks that should be made. If the quantity is 0, it means the pile is empty. If the inserted money is less than the price, it means the user should insert more money. And finally, if we cannot allocate the required amount of money to return back the change, that should be an error too. You can see we use a canAllocate method of the money value object, which doesn't yet exist. Let's add it. So basically, in the allocate method, we adhere to the command query separation principle as well. We will have one method checking that the allocation can be done and the other one performing the actual allocation. So to validate that the allocation is legal, we need to execute it first and then compare the resulting amount of money with the requested one. If we don't have enough change, the amount should simply differ. And I'm making these changes here to add the validation before proceeding. Alright, these are all checks to be done before buying a snack. Returning an empty string in case all validations are passed. Now we can call this method in the buy_snack method like this, and remove all these checks. Very good. As you can see, extracting all the checks in a separate method makes the code much cleaner. Finally, we need to use the buy_snack method in the viewModel. So basically, if there is any error, we just show that error to the client and don't proceed further. You can see if I insert a single dollar and try to buy a chocolate which costs $3, it shows that there is not enough money to make the purchase. And if I insert $20 and try to buy a $1 snack, it displays that there is not enough change. Very good, we now have a fully working model of the snack machine. In this module, we talked about repositories. Repository is a pattern the purpose of which is to encapsulate all communication with the external storage. It's important to keep in mind a general rule of thumb: there should be a single repository per each aggregate. Another guideline here is that public methods of repositories work with aggregate roots only. If you need to get a sub-entity, retrieve its aggregate root first and only after that look among its sub-entities. But keep in mind the guideline we discussed in the previous module. Try not to expose sub-entities outside of aggregates wherever possible. Repositories work with whole aggregates, meaning that they should perform saving and retrieval of all sub-entities without additional effort from the client side. It is best achieved by configuring proper mappings in the ORM. You also saw an example of working with reference data. It's a good practice to declaratively define such data in the domain model. It helps simplify the code and increase its readability. In the next module, we will talk about bounded contexts. We will introduce a second bounded context and will discuss different ways to express them in code.